Hello everyone and welcome to our presentation on the Denver International Airport case study. We will be covering the challenges and innovations involved in building one of the busiest airports in the world. Our team, Tham Xue-yi, Chai Jeffrey, Davis Fan Sun-ge, and I, Wong Wen-sing, will walk you through the project's background, solutions, and lessons learned along with comparison to similar projects in Malaysia. Denver International Airport, or DIA, is located in Denver, Colorado, and officially opened on February 28, 1995. The airport was designed to be a modern, efficient, and expensive facility to meet the growing demand for air travel and serve as a major international hub. DIA is the largest airport in the US by land area and the second largest in the world with the longest runway in the US. As of 2023, DIA ranks as the 5th busiest airport in the US and 20th busiest globally, as serving over 64 million passengers annually. Stephen International Airport had served Denver for 65 years but became increasingly congested as the city population and economy grew. Its outdated infrastructure could no longer meet the rising demand for air travel. This highlighted the need for a new airport to accommodate increasing air traffic and create a modern, spacious, and efficient hub to support Denver's future growth. However, the development of DIA faced several challenges, including technological issues with the baggage handling system, design inefficiencies such as long concourses, budget overruns and construction delays, as well as political conflicts and environmental concerns. One of the most ambitious features of DIA was its automated baggage handling system, which aimed to improve efficiency using conveyors, automated vehicles, and robotics. Unfortunately, the system was not fully tested before the airport's opening, which led to significant technical problems and ultimately it failed and was abandoned. This highlighted the challenges of implementing ambitious technology on a large scale. Additionally, while the single hub design of DIA streamlined passengers transfers, it also resulted in long concourses that made it inconvenient for travelers moving between gates. Combined with the baggage system collapse, these design issues caused operational delays and inefficiencies in the early years of the airport's operations. Financially, the initial budget for DIA was set at 1.7 billion in the 1980s, but due to unforeseen problems, design changes, and construction delays, the cost balanced to nearly 4.8 billion. This setback pushed the opening from 1993 to 1995, leading to significant cost overruns and attracting public and media criticism. Politically, conflicts within the Denver city government also delayed decision-making and cost management disputes. Furthermore, concerns about land use and environmental impact further hindered approval for the airport's development. While these political issues were significant, the technical and logistical challenges play a more central role in causing the delays and cost overruns.
Good day, I'm Jeffrey. These are the alternatives and solutions for DIA. It can be divided into 4 parts, which are innovation and technology, engineering best practice, financial people and resources, and finally, organizational and strategy planning. For the innovation and technology, thorough testing and phased implementation is very crucial. Technologies like DIA automated package handling system should be intensively tested in a controlled environment and implemented in phases to identify and resolve issues early. Second, balancing innovation with the adoption of proven technologies can reduce the risks. By mixing cutting-edge and reliable solutions, it can ensure a balance between advancement and standard review. Thirdly, collaboration with technology experts is vital. DIA's venture investment is starting the collaboration early ensures smoother planning and implementation. Next, for the engineering perspective, several best practices can be carried out, including prototyping and incremental testing. This can simulate the real-world conditions to identify the potential flaws before full-scale deployment, reducing the risk of system-wide failures. Next, modular design principles allow independent testing and upgrades, preventing cascading failures, enabling error flagging. Lastly, advanced simulation tools help to predict the risk and optimize the system designs. This can avoid a costly error during implementation. For the financial people and resources, financial management and resource allocation were a major challenge for DIA. Tighter budget control and contingency planning are essential. Setting aside the contingency funds can help to manage unforeseen costs and prevent budget overruns. Next, public public-private partnership PPP can also reduce the financial burden on the taxpayers while leveraging private sector expertise and funding. Strong project management and leadership is also playing a vital role. A senior management team with clear accountability ensures better oversight and prevent the delays. Finally, we move to the organizational and strategy planning. The stakeholders' engagement should begin early to align with objectives, address the concerns, and reduce the conflict. Moreover, improved coordination between teams can be achieved by appointing an integrated project manager and using collaborative tools like BIM for the better communication. Last but not least, developing temporary systems for immediate needs such as BIA with its package system ensure partial cooperation and adaptability in face of setbacks. That's all from me. Thank you.
Next is the solution that we propose. The solution consists of 4 parts. First is the thorough testing. We need to test new systems in control environments to identify and resolve issues early. Second is the phased implementation. We have to roll out system gradually, starting with smaller applications such as one concourse to manage risk and improve reliability. Third is cost efficiency. We can avoid costly repairs by resolving issues during phased testing and deployment. Fourth is stakeholder confidence. We can build trust in stakeholders such as airline and passenger by proving system reliability on smaller scale before full implementation. Furthermore is some recommendations which are strategies for accomplishing the proposed solutions. There are 5 of them. First is stepwise technology rollout. We need to begin with smaller deployments to refine systems. Second is centralized leadership. We must establish a strong team to manage timelines, budgets, and communication. Third is financial preparedness. We can allocate contingency funds and involve private partners for funding and expertise. Fourth is progress tracking. We should create a roadmap with milestones for monitoring and timely adjustment. Lastly, government and private partners should know their own role. Government should focus on regulatory oversights and environmental compliance, while private partners should focus on technical implementation.
Now I'll move to the part of the benchmarking with Malaysia case. Let's dive into the comparison between the Denver International Airport (DIA) and Kuala Lumpur International Airport 2 (KIA2). Both projects faced a significant challenge during their developments. DIA initially budgets at $1.2 billion escalated to the $5 billion with a 2-year delay in its opening. Similarly, KIA2 budgets doubled from 2 billion ringgit Malaysia to 4 billion ringgit Malaysia, and it also experienced multiple delays. A major issue for both projects was the failure of their automated badger system. At DIA, this was due to the insufficient testing, resulting in significant operational insufficiency. KIA2, on the other hand, faced system malfunction and integration challenge, delaying opening and increasing the cost. Another common factor was the poor stakeholder engagement and the project management. DIA struggled with the coordinations among the stakeholders, while KIA2 faced criticism for the insufficient oversight and communication by its management team. So from this case, we can draw 3 critical lessons. So the first one is the phased implementations of technology can significantly reduce the risk. And second, engaging the stakeholder early and maintaining the clear communication throughout the project's life cycles is essential. And finally, with the third lessons, is proactive risk management and effective project leadership are key to avoiding the delay and also the cost overrun. Conclusions: DIA and KIA2 project highlight the critical challenge opportunity in managing the large-scale infrastructure developments. The both projects highlight the possibility of ambitious innovations like automated badger system, but also show the risk of using the untested technologies without the proper preparations. DIA had to abandon its system due to the poor testing, while KIA2 faced the delay from the integration problem. These cases also underline the importance of effective project management and leadership. DIA suffered from the weak coordination and oversight, and the KIA2 exposed the gap in the communication and supervision. This failure led to the significant cost overrun and delay timeline. Importantly, this experience provides valuable lessons for the future projects. Success requires a balanced approach that combines innovations, strategy, risk management, and also the stakeholder collaboration. So by adapting the phased technology rollouts, by fostering the robust engagement and also the proactively addressing the risk, future projects can be better navigate the complexity and meet the deadlines and also the control the budget. Ultimately, this lesson paved the way for the efficient, sustainable, and reliable infrastructure development, and ensuring all the ambitious goals are achieved without compromising the functionality or long-term success.